Welcome back. This is the final tutorial on pandas, and this will also bring to a close our session on data analysis. So in this module, we'll talk about some additional features of pandas, as well as have an introduction to very basic visualization using seaborn package, as well as this very simple statistical model using stats model package. Okay, and I also would like to finish this module by talking about data analysis, and I'm going to do this right now up front. So far, we've talked about data preparation and data analysis. I just wanted to place them in context. When you think about data science and data analytics, it basically involves multiple stages in working with data. It assumes that you have some data that you already acquired, cleaned, and prepared for analysis. And that's partly what we did in the first track, data preparation module. All right. And once you have some data that you acquired and you cleaned, you also need to manipulate the data, analyze the data, right? That would be the second part, second track. You can use pandas, especially pandas data frame, to join tables, to do really powerful things that are usually very, very hard to do in Python or even in some of the other languages, like MATLAB, for example. Okay, so while I say that this is data analysis, I just want to say that what we've been doing a lot is mostly data manipulation, which kind of overlaps with data analysis. Overlaps with data preparation. Okay, just wanted to put it out there so you have some context. And again, I want to mention that pandas, which we've been working on so far, is very good for data manipulation. We started with NumPy. This is really basic data structure, the ND arrays, and pandas is built on NumPy, but is a lot more powerful. I would say that NumPy is a lot more low level in terms of manipulating arrays, whereas pandas is excellent at a higher level. You can work with Excel-like object, Excel-like structure, and to be more specific, I would also say that database-like structure, multiple tables. Okay, and you can join, you can do a lot of things, powerful things, which you're not really looking at it, but if you're more interested in this later, again, I referred you to pandas documentation in the last class. I advise you to go take a look. If you already know something about databases, it's really easy jump from there to using pandas for manipulating data, joining tables, doing different things to it. Okay, we've been doing this indirectly in selecting out some columns, selecting rows, and so on. So it's really, if you think about it, it's kind of like some of the database operations, almost like using a SQL query. But again, you don't need to know any of those terminologies for our class, right? We are working with data that fits on an Excel worksheet in some ways. Okay, but I just want to put it out there that it is very powerful data manipulation tool. Okay, and towards the very end, I'll also show you some basic visualization things that you can do. Really not with pandas here, but more with the seaborn package, right? And then I will finish this module by running a very simple statistical model, linear regression, using the stats model package. Okay. So as usual, we're going to be importing a couple of packages, import pandas, import NumPy. And if you notice, again, I just wanted to show this to you. For some variation, instead of saying import pandas as PD, I'm just going to leave it as is. Okay, I say import NumPy and import matplotlib.pyplot as PLT. For this, it is a bit long, so I would like to use a nickname for this, PLT. Okay, and we won't be using this right away. We'll use it towards the end. Okay, and I don't want to import the last two packages yet. I will show them to you when we get there. Import seaborn and import stat models. All right, so let's get started. The first thing we are going to do here is basically call on pandas to read a file that's already present. So I have this data, and if you notice, again, the format is very similar to the format we use for reading files in the files module. This basically signifies that everything that follows is a raw string. That's what R quote means here. R quote means here. Okay, so this basically means here's a folder, and I put a file right here. Okay, and if you're not really sure if this is working for you, another alternative is don't use a folder. Just put the Boston H on the same folder where the Jupyter notebook is, and you can safely ignore data and the slash sign here. Okay, again, I mentioned this before. when we talked about files, if you're using a Mac, the slash should look like this. If you're using Windows, the slash should be in the opposite direction for this to work. Okay. So here we have some data that we are trying to read, and again, pandas has a built-in, read CSV function, right, that I'm invoking. So here's my data, Boston h.csv, and I'm basically making this false just for efficiency purposes. So let me just leave it at that. I mean, for small data sets, leaving this out shouldn't make a big difference. Okay. I'm just doing this for efficiency purposes, especially important if you're reading in data that's millions of rows, or let's say tens of thousands of rows. Okay. And again, the interesting thing here is that I'm not really invoking data frame, because the process of me reading the file using read CSV, again, I'm calling it from pandas. So the output that I get, which is assigned to this variable data, right? Again, I could call this anything I want, df, something like that, right? That variable happens to be a data frame. Okay. So when I run this, when I say print linked data, it's going to show me how many rows of data, right? How many rows are there in the data, and length of data.columns. And again, this format should be familiar to you. This syntax should be familiar to you from the previous module, right? If I say length of data columns, it should tell me, okay, what's the number of columns that are present. Okay. So let's run this code. First, let me run the first cell, make sure that I imported everything. So everything is good. No error messages. I'm running this again. So this is basically telling me this data set. Again, this is a very famous data set that I oftentimes use in my introductory data mining class. And this has 506 rows, right? And 14 variables. Okay. So I'm going to explain to you, or I'm going to give you a very, very brief description of the data set a bit later, but I would also encourage you to do a Google search on Boston dataset. Boston without the H dataset, and you should get plenty of links that describe what the individual columns actually mean. Okay, so let me run this. Let me run the the next cell, print data.columns. Now, not only do I want to know how many columns are there, I actually want to know what are these columns. Okay, what are the labels that we use? So literally, it's printing me the first row here. That's basically telling me that there are 14 variables. So these are called CRIM, CRIM, zone, ZN, indus, chas, nox, RM, age, and so on. Okay. So again, when you look at it like this, you're probably not going to know a whole lot. Okay. And again, I'm going to encourage you, I'm going to ask you to Google Boston dataset, right? You should be able to see a page that describes to you what these individual variables mean. Okay, I'm not going to spend time talking about it, but rather let me talk about what we can do with some of these variables, and during those times I'll explain what those variables are. Okay, so just to make sure that this data, the variable data, is actually a data frame, let me check type data. What is this data type? So it tells you it's data frame created when I read the file directly. CSV file, again, hopefully you know this, comma separated variable. I can open these files using a Microsoft Excel as well. Okay, so again, you can try doing that as well. And just to show you, maybe I should go to the Python Jupyter notebooks that I have. So here's my folder data, right? And here's where I have a bunch of files. So if I click on it, I should be able to see it. So here are the first row contains the variable names. The rest of the rows contain the actual data, and it's CSV, comma separated values, because each value is separated by a comma. That's it. All right, no magic to it, nothing more to it. All right, so let me close this. Let me get back to the Jupyter notebook. Okay, so now again, if you recall from the last class, if I just wanted to examine the first few rows just to get a sense of what these variables look like, what type of variables are these? Are they numeric variables? Are they categorical variables, right? So to get a sense of what they are, let me run this command here, and you actually see that. So here are the variables, right? And again, pandas automatically indexed the rows for me. So again, if you recall from the last class, I should be able to use a different command, idx, to actually just slice or get a couple of rows that I want. Okay, by default, head is going to give me 5 rows. If I want 10 rows, I can type in 10 here. It should give me 10 rows, right? tail would give me the last few rows. Okay, so you can see that most of these variables here, in fact almost all of them, seem to be like they're numeric, meaning here's an example of a variable that we'll be looking at a bit later. This is really a median value, okay, of a housing prices in Boston. Okay, and again the only tricky part here is that this is not just a median value of an individual house, but if you really think about, for example, New York, and think about New York is composed of multiple localities. Let's say, as an example, let's say Upper East Side, Upper West Side, Midtown, right? And within Queens, a couple of neighborhoods, and Brooklyn, a couple of neighborhoods. And let's say we have a list of 500 neighborhoods within New York, and this gives you an average, not even average, median value, okay, of price. It's somewhat similar to an average, okay? Again, I'm not going to explain what median is for this lecture. Similar to mean, okay? So it gives me the median value of housing price in each neighborhood. And so each of these values that you see here, right? For example, this is a number of rooms in a house. Obviously, if it's a single house, right, the number 6.575 would be absurd, but because it's a neighborhood, the number of rooms in a neighborhood, let's say rooms in Upper East Side, right? So the average happens to be 6.575. So what you see here, each row represents a neighborhood, okay? So those are the numbers here. So this is the number of rooms, this is the age of the house, and so on, okay? And this is an interesting variable called Charles, CHAS. It only has two values, even though you cannot see it here. It's 0 and 1, okay? So 0 means, if I recall correctly, houses are not close to Charles River, and 1 means houses close to the Charles River, okay? And so you can even think about, do you think the houses next to Charles River would be higher or lower in value, housing prices, as opposed to houses that are far away from the river, okay? So here are some indicators, okay? Here are some variables, and here are the rows, individual rows with data, okay? So now what I want to do is, instead of working with all 14 variables, let's assume for our purposes we want to have a manageable subset. So all I've done here is I've just selected out a couple of variables. I think this is 14, and I think I have about 9 variables here. So all I had to do now is DFB equal to, right? And since I did not do the previous, since I only said import pandas, so I have to say pandas dot data frame, okay? If I said from pandas import data frame, then I wouldn't have to specify pandas here, okay? So this is the variable that's the value is going to be assigned to at the end. Hopefully it'll be a data frame if everything is right? So pandas data frame, and data, this is a variable that's right here. We read this in from the CSV file, right? And I say, and basically this command is saying, have a look at this variable, which is data frame, and it's telling Python that from that data frame only select these list of variables. And if you notice, this is a list. So this is all there is to it. So if I run the command, I should have a second data frame that's like a subset of the first data frame, okay? So it seems to have run properly. Let me see if it works. I'll run this. So you can see, you can compare that it's a subset, right? So you have all of the rows. I'm not cutting any of the rows. You would still have about 500 rows of data, 506 to be exact. The only thing I ignored are some of the columns that I decided I don't need to work with, okay? So we have a subset of data here. I call this DFB. So from now on, when we work with this data set, we are going to be working with DFB, okay? So let's see what we can do with this, okay? So the first thing that we may want to do is try to understand the data a little bit better, right? So again, hopefully if you remember your very basic stats, if we do that, so first thing we may do is look at the distribution. We might want to see, for example, in this variable here, Charles, it only takes two values. How many zeros, how many ones, right? And let's say that here's another interesting variable called RAD, and how many unique, let's say that this has multiple levels. Let's say this has 8 levels, 9 levels. it takes values from 1 to 8 or something like that, right? How many times do we have ones? How many times do we have twos? Okay, so what we are trying to do here is something called a value counts. Okay, and so let's pick RAD, okay, this variable here, because I told you here that chas only has 2 values, and we're going to run this soon, but we don't quite know. I actually don't remember how many levels the variable RAD has. Okay, so let's see if we can come up with this value count. Okay, kind of a histogram, frequency, to be more accurate, frequency distribution. Okay, so I have a variable called rad underscore count. To this I assign the data frame DFB. I only want one column. Again, this is the same syntax that we looked at in the last module. If I only wanted one column, this is how I'm going to specify it, right? Within square brackets, RAD. And again, I think I mentioned this in the last class, but I don't remember. If you just left it at that, of course, this is going to be one column with all these values, and that would be a pandas series object, which is what we started with, right? So now we select out this one column, and within that, by invoking this function dot value counts, okay, for the time being, ignore this comment here. Okay, this is the comments here, comment section here. By invoking this function value counts, right, I'm basically coming up with a frequency distribution. So let's run this and print this new variable that we just created. Okay, so here you see, interestingly, right, so it seems to have multiple levels. I don't quite know how many levels, you may have to count it, but you also notice that it seems to go from 1 to 8, but you also have something called 24. So here is a part, that's more to do with data understanding. When you see things that you do not understand, sometimes maybe you know what that variable means. And in this case, I think it means access to highways, again, if I remember it correctly. But regardless of what the variable is, to me, something interesting is going on. So you have, on the one hand, there are 8 contiguous numbers. So maybe it's a categorical variable. It's entirely possible. Maybe it's an ordinal variable, meaning the order matters. Then if these terms do not mean anything to you, don't worry about it. You can ignore it for our class. But if you want to do even basic stats, you should know what categorical is, what ordinal is. Okay? The thing that stands out for me is this 24, right? So I don't quite know why there is another label or another value here called 24 that's so far apart from the first 8 levels. Okay, so if it were up to me, then I would go out and investigate, check what this 24 actually means, because if you do not do that, and if you run the model, maybe the results that you get, maybe I wouldn't trust on it. Okay, so that's all I'm going to say. So doing these frequency distributions and doing this initial data exploration helps you understand the data. Okay, so here's what we have now, right? And let's say that I don't want to have the frequency distribution displayed like this. Rather, I want them to be sorted in some order. But even here, I'm actually saying sort is false. Okay, so let's see what happens. Right, I changed it. I say actually false. Now I actually have something that's sorted. Okay, so you need to set this so that I can sort. You have the ability to sort it. Okay, so now we've done some frequency distribution, so you can also kind of see that there are ways of sorting this frequency distribution. So let's move on. The other thing that I wanted to mention, again, one other interesting thing to know. Okay, so right now it seems like I have a bunch of features we are looking at. Pretty soon, when towards the middle of this, not towards the end of this module, I'm going to try to give you a workflow. So what you might want to do, right, when you have a data set, okay, kind of a workflow. So hopefully some of these features we learned would be useful then. Okay, so here's how I would get a frequency distribution. Okay, and now sometimes, and in this case, I'm not so convinced. What kind of variable do you think RAD is? Okay, right now it looks like this is a variable that might be categorical, meaning it has multiple levels, right? Imagine gender as a categorical variable with 2 levels, male and female, right? So it seems like a categorical variable with maybe 9 levels, and this is kind of a strange level. I don't know. And maybe 1 means, and if it is, again, maybe, you know, based on my recollection, let's assume that this variable means how close are you to the highways. Maybe this means it's very close, and maybe this means it's not at all close, or something like that. Okay, I'm just getting conceptual, focus on the concepts here. Okay, so if that is the case, maybe what you might want to do is, when you're running a regression model or something like that, maybe consciously you decide that I have a lot of levels, right? So I might as well use this as a numeric variable, continuous variable. So that's a choice you can make. Okay, whether it's appropriate or not will depend on the context. Okay, and again, if you ever want to do this for a variable that looks like this, whose frequency distribution looks like this, what you should do is drop 132 observations. This basically means there are 132 rows that have the value 24, right? I would do something with this, either drop them and then use the remaining variables and then make them numeric. Okay, again, conceptual things, statistical concepts, I'm not going to test you in the exam. All right, all I want to show you is that if you think that something should be numeric, it's not a bad idea to use this function and take this column dfb rad, right? And I'm actually rewriting this. I'm actually, you know, changing this actual, because you already have a dfb already. That's that column, right? So what I do is I take that column and I convert that to numeric values. Pandas dot to numeric function, right? When I apply this to the existing column, here I'm renaming this the same name, which means it's going to be overwritten and all the values inside would be numeric. Okay, and if I run this, you should be able to see this. And so the other thing that I want to add, again, this is about the workflow, right? In general, it's a good idea for you if you think that some of these variables need to be numeric, right? Even though they look like they're numbers, right? You may actually want to convert all of the variables that you think should be numeric, right? All of them should be converted to numeric using this function. So when you start, maybe you have a data frame, apply this to all numeric things in one place at the very beginning, right after you have the data frame. Okay, just to avoid surprises. All right, so let me go further down here. So now if I try to do the same thing for Charles, the variable Charles, right? And in this case, I would say that every variable other than Charles should be numeric. This is categorical, has only 2 levels, 0 and 1. Okay, and just as you can explicitly specify that something should be numeric, you can also explicitly specify that something should be categorical. Okay, and again, I'm going to show you the command for this a bit later, but right now let's look at how many zeros and how many ones do we have from among the 500 or so rows. Okay, so again, if you take a moment to think about it, right, how would you do the frequency distribution? It should be pretty similar to what's here. The only difference would be Charles. Again, you really, for Charles, you don't need to do this because it's a categorical variable. You don't need to apply the to numeric function because that's the only variable in this data set that seems like it's categorical. Okay. All right. So now here we have chas underscore count equal to the data frame, right? That's Charles within square brackets dot value counts. Okay. And here I want it to be sorted, so I put this in here, and I'm introducing another attribute, normalize equal to true, which instead of giving you a raw count, right? This is a raw count. When you add them all up, it's going to come to about 506. That's why it's a frequency distribution. When you say normalize is true, it's going to give you percentages. Okay. So let me run this. So here you have zeros and ones. So about 93% of the rows have 0 as a value. About 7% have 1 as the value. That's all this means. Okay. And again, you should already know this. If you by any chance make a mistake and you spell it incorrectly, chas has to be all caps, right? Then you will have something called a key error. You should know this already. from previous experiences, so you don't want to do this. Okay, and let me just clear this up. Okay, so now just another thing to remember, I can do the same histogram. There are multiple ways of doing this, a group by function. The idea here is that I'm just going to go up to the data frame here, right? The idea here is that I can pick any of these variables, right? And I can group them by a specific value. Okay, again, it makes more sense if it's a categorical variable. I'm basically saying group by certain things, right? I grab a column, ideally categorical, and I'm saying group them by zeros and ones. Okay, if you know databases, you probably know what I'm talking about. Okay, so let me come down here, group by, and this is the syntax for this. So this essentially accomplishes the same thing we did in the previous couple of operations, frequency counts. Okay, and so similarly I can replace Charles with RAD or anything else I want. Okay, I should get the same value. Okay, here it's raw numbers because I normalized it here, so I can erase this. It should be the same. You see that 471, 471. So both of them different ways of doing frequency distribution. Okay, so that kind of brings to an end most of the things we've done with pandas. Now what I would like, still some more stuff left, but now I would like to switch gears and move to visualization. Okay, so here you need to import a package called seaborn, right? You see that here. The tricky part here is that you actually don't have this package installed in Anaconda by default. So what you need to do is to make sure that this package is installed in your machine, right? So what you need to do is maybe pause this video now, close the Jupyter notebook, especially including the terminal that's running in the background window. For example, I have something like this that's running in the background window. You should have a similar screen also for Windows. Make sure you close it, right? Close all of the Chrome browser and everything, and then reopen terminal, right? It should be emptier, and all you need to do is make sure you close it, reopen it. There should be a prompt, and just type conda install seaborn. That's it, as simple as that. Then what it's going to do is it's going to give you some commands. It's going to process the package, unpack it, and it's going to ask you, do you really want to install it? You say yes, type Y, and you'll be set to go in less than a minute. Okay, and then this kind of a procedure should work for most packages. And again, you would do conda install only if you have Anaconda, right? If you don't have Anaconda on Jupyter notebooks, then you may need a different manager. Like it could be, oftentimes it's the most commonly used is pip install seaborn, something like that. Okay, and this is a lot easier. Conda, pip might be a bit more tricky. Okay, so this should work for most packages. And again, if you want to know more about seaborn, here's a link that should have more information on data visualization using seaborn. Okay, so I leave the link here up for you to explore. Right now what we are going to do is some simple exploratory data visualization. Okay, so as usual we would basically do this command, Jupyter magic function, the percentage, matplotlib inline, meaning do the graphs inside the Jupyter notebook, right? And again, remember the difference between matplotlib and seaborn is somewhat similar to NumPy and pandas, right? Matplotlib is built into pandas, but it's not really easy to use, and so you package like seaborn makes things much easier for you. Okay, so let me run to make sure that I don't have any errors here. So I certainly have seaborn installed. If you don't have it installed, you're going to see an error message that it basically says I don't know what seaborn is, right? So make sure that you have it in one single, in a cell, a single command, run it, make sure that there are no errors. Okay, now here's the syntax, seaborn dot count plot. Okay, you're going to see what kind of plot it is in a second. Count plot x-axis, x equal to whichever variable I'm interested in this case chas, and from which data? Data equal to DFP. Okay, now my x label. So what should I call the x variable? It's, let's say, houses next to Charles River, something like that. This basically means are they close to Charles River or not, right? And I'm basically specifying the title here, number of houses next to Charles River, title of the graph. Okay, let me run this and see if something happens. There you go. So houses next to Charles River, if it's assigned 1, you see that most of the houses are not next to Charles River, some of them are. Okay, that's a percentage. All right, now similar to that, right, that's the distribution again, right? It shows me the distribution, but I call it count because it's a frequency distribution, right? It's a categorical variable, 0 and 1. And what if I have a variable such as, I'm going to go up here so you can see it, MUDV, that's not really categorical, it's a numeric value, right? It can take multiple values. So it's a numeric continuous variable. What kind of plot would I use, right, to understand the distribution? So the name of the plot is distribution plot, dist plot, right? So it's seaborn dot dist plot, and which variable? MEDV. So DFB in square brackets MEDV. Okay, and let's ignore this for the time being. Okay, let's run the basic one. X label is going to be the median price of houses, and the title could be, I just put a title here. Again, you can do whatever you want. Let's say distribution. Distribution plot for MEDV, something that's appropriate, descriptive. Okay, so let me run this. So here you see the distribution plot for MEDV. So you see a couple of things, but here is a distribution plot for the median price of houses. Okay, and again, if you're in a stats class, now you'll be worrying about how skewed is this distribution, how normal is it, right? All those sorts of questions. Are there any outliers? We won't worry about this for our class. Okay, so what I'm going to do is now I'm going to go back here, comment this out, right? Run a slightly different variation and introduce some other parameters. This here is something that you might want to remember. Drop NA. This is important. Let's say if your data set has missing values. If you put this in here, it's basically going to say drop all rows, right, where MEDV is missing. Useful thing to have. Okay.